welcome to the Micronaut podcast. Happy 2023. My name is Sergio Delamo. I am your host, and I am here today with Mark Sales. How are you, Mark?
I'm well, thank you. Happy New Year, everyone.
Happy New Year to you too. Would you like to introduce yourself to the audience, Mark?
Yeah, sure. My name's Mark Sales. I work for AWS, and I'm a specialist solutions architect. So I help customers with our serverless services. So things like API Gateway, Lambda, SNS, SQS. And I'm also really interested in Java and open source. So I lean heavily into those technology areas.
For agenda, we are getting ready for the conference in 2023, but I have an online talk on the Brighton Kotlin user group on January 17th. I actually met Lee, the organizer of the Brighton Kotlin user group, in an event that I was hosting with Mark in 2022 when we were talking about AWS Lambda and the Micronaut framework. I think it was in London, or maybe it was in Dublin when we met Lee. Don't remember anymore. So yeah, if you are able to join me, that's going to be an online event. It's the evening of the January 17th, the evening if you are based in Europe. It's free, and we're going to talk about getting started with the Micronaut framework. I will try to do my talk with Kotlin, which is going to be a news for me. So let's see how that goes. Do you have anything on your site, Mark?
No, not at the moment. I'm in conference application hell. So yeah, if anybody is looking for public speakers to talk about Snapstart, then please, feel free to reach out to me on Twitter.
As part of the agenda, I would like to cover Micronaut 3.8.0 release, which was announced last week. This is our latest minor release. As you know, in the Micronaut framework, we follow semantic versioning, so minor releases is where the presents are unwrapped. So it was really well targeted for Christmas. Let's say it that way. We support, let me go through, I have the blog post here in front of me. Let me go through the biggest features, and I'm going to take the opportunity to talk with Mark about a couple of AWS related features. Taking the advantage of having Mark as a host. So Micronaut 3.8.0 supports GraalVM 22.3.0. So that's the latest version of GraalVM. We have support for probably the biggest or the most upvoted feature ever, which is in Micronaut Data. We have a ticket to support multi-tenancy, which was really, really demanded by the community. We have not support in Micronaut Data for data source and a schema multi-tenancy modes. So that's the idea that you could have two databases, one database per client, for example, and your Micronaut application could basically, I don't know, maybe using a subdomain or something like that. You could essentially your application code is the same, but you're essentially serving different partition data, basically. So if you have a SaaS application, you probably are thinking about multi-tenancy. We have on the plans to support also multi-tenancy with a discrimination column. That's not there yet in Micronaut 3.8, but we are working on that. So stay tuned. Check it out. If you give us feedback about if the multi-tenancy solution works. We have another module called Micronaut Multi-Tenancy, which contains the logic for resolving the tenant resolver. So whether you want to resolve the tenant with an HTTP header, with a subdomain, a fixed tenant resolver, things like that. So, or maybe session-based. So check it out and let us know. We have also a big release in Micronaut Data as well, supporting Azure Cosmos DB. So you can use the repository patterns with Azure Cosmos DB. So if you are on the Azure cloud and you want to check Cosmos DB, now hopefully you will have a better developing experience with Micronaut Data. We have a couple of new features in Micronaut security. One of them is support for PXE, so proof key for code exchange. This typically what we will do is if the authentication server you are working with tells you that they support any code challenge method, either plain or S256, we will essentially do the Pixie exchange for you. So it's quite transparent for you. Some people, Micronaut applications typically, when working with authorization code grant, is Pixie was not as required because you were not using something like the implicit flow, but some people really needed this because it was required by the organization that Pixie was supported. So we have you covered now. So that's available in Micronaut Security 390, which is part of Micronaut 380 BOM. We have feature that I am quite excited about, and I think is quite exciting in terms of serverless as well. And now that I have here Mark, that's great to talk with him about this. Is we have ahead of time optimizations for the Micronaut security module. So let me describe a scenario which you may face when working with AWS Lambda and Micronaut. So you may have, for example, you may be working with Amazon Cognito, which is the authorization server offering by AWS. And the way it works, our OAuth 2 integration, when you are working with an OpenID Connect provider such as Amazon Cognito, is when the application is started, we do a network call to Cognito to essentially download the server metadata. Based on what the authorization server tell us, we configure the Micronaut application, right? So we fetch this information via network request, and with the information, we essentially register some singletons into your application. And then often these authorization servers, they will also expose their public keys that they are gonna they're gonna assign ID tokens and access tokens, and they are gonna expose the public keys that they use to sign those tokens in an endpoint, basically. So one of the things that we typically need to do in Micronaut security is before we are going to validate the signature of a JWT, we are going to have to do yet another network request to fetch those keys. So as you can see, these are two network requests that is going to be time consuming in every deployment scenario, but this is especially more severe in serverless because you are going to basically incur on those costs in every cold startup, right? We are going to talk later with Mark about how AWS Snapstart is going to help you reduce those cold startups. What we have done in Micronaut security is that you can opt in. So this is an opt-in feature. If you want, if you know that your authorization server is, you are comfortable of doing this network request on build time instead of on first request, you can configure Micronaut security to do that. And this will basically, what I am seeing is, as you can imagine, any network request can go from up to 1 second. So this could basically save you 2 seconds startup time. So as I said, this is opt-in. It's really easy to configure. Check out the Micronaut security documentation. This is an area that I am really excited about. I think we could do something similar for AWS Secret Manager or any secret manager solution that you are using, something like HashiCorp or Vault or something like that, because we could do the fetching of those secrets also on build time, and that will basically get rid of all these network penalties that you typically will pay for when you are working on servers. You have to fetch secrets to configure your application. You have to fetch security configuration from authorization servers, and those network requests, they need to happen, right? So they either happen on a startup, or we could offload them to build time, and that's what we are doing. Kind of the philosophy of Micronaut of offloading as much as possible to build time. So if you are interested on checking that out, please do give us any feedback. I'm really excited to see what the Micronaut community is able to do with these optimizations, and any ideas that we can apply are more than welcome, because I think for certain scenarios, I think for many people the trade-off is going to be more than worth it. So check it out.
It's really, really interesting, and I think you hit the nail on the head, especially with serverless, because you just have more scale-up events, more JVM starting from scratch effectively. So each of those scale-up events is going to have to do those make those network calls. So you have a much bigger penalty. So bringing all that ahead of time is absolutely fantastic. From the trade-off point of view, just to help my understanding, so the only trade-off is if the server's certificates change, you'd have to rebuild your application, or is there something else?
For the authorization server, if the authorization server configuration changes, you will have to rebuild your application. For the JSON Web Key sets, there is almost no penalty because if the JSON Web Key sets, they will be rotated, right? So the public keys that typically an authorization server they typically expose two keys. One is the key that they are actively signing, and the other is the key that they used before. So when they rotate keys, they are basically adding one new, and the active goes to passive. But if you wait long enough, all the keys they will be rotated. So what we do in Micronaut Security is we will attempt to refresh those keys upon failure.
Fantastic.
For that scenarios, you will not need to rebuild the application. For the authorization server configuration, just to explain people what that means is on a startup, and this is really great from the industry has agreed on having this OpenID auto configuration specification and all the players. So Amazon Cognito, Google, Keycloak, Okta, OutZero, all of them, they are compliant to this thing, right? So they exposed an endpoint where they basically tell frameworks such as Micronaut or Spring or Quarkus or any other framework, they tell how the authorization server is configured. And what I mean by that is they tell us where the token endpoint is. So if the token endpoint in the authorization server is /token, or maybe it's /b1 token, they are going to tell you the routes that you have to call. So the frameworks, in order to configure your applications, we have to essentially fetch that information to essentially know the routes. So that information typically will not change. It will depend on your authorization server, of course. But Cognito typically is not going to change where the token is exposed. So I see that for many people, this is going to be like a trade-off that they can do. But of course, you have to understand the implications of moving things to build time, and hopefully we really convey those implications in the documentation.
Awesome. That sounds fantastic.
Another thing, really talking about AWS Lambda, is we added a new CLI command. So this is currently not exposed on the web interface. So if you go to launch.micron.io, this is like a web application to generate Micronaut projects. We have the same experience on the Micronaut CLI, which is a command line application that you can easily install if you are using SDK man. It's SDK man install Micronaut, and that will install you the Micronaut CLI. And we have a command called create AWS Lambda, which is going to be an interactive prompt. It's going to ask you questions. It's going to guide you. So it's going to ask you questions such as how do you want to write your Lambda? Maybe you want to write with controllers, because this is going to be a Lambda. This is going to be like a Lambda with it's going to respond to HTTP request, and it's going to have multiple controllers. Or do you want to write like a Lambda with just a handler, because maybe your Lambda is going to respond to an S3 event, maybe. And it's going to guide you through questions. It's going to ask you, for example, do you want to use infrastructure as code with CDK, which is something that we support since Micronaut 3.4.0. I was really interested on building, and I think my dream is to basically bring this approach to the web as well. I think we are in a point in Micronaut where we have so many features and so many kinds of applications that sometimes the current UI on Micronaut Launch is a bit constrained, right? And depending on the application, so if you are working with Lambda, but if you are working with Azure Functions or with Google, I don't know, for example, we in Micronaut 3.8.0, for example, we support Google Cloud Events, right? And it is difficult in our current interface to basically expose those features to users, right? And with an interactive prompt, it's kind of having a conversation with the developer, and we help them make the decisions about how they want to build the applications. So the way we are trying to make people discover features is talking about them, such as we are doing in the podcast, having Micronaut guides, but also when they want to generate projects, right? And I think this hopefully the community likes this new command line command as much as I do. And we'll talk more about AWS Snapstart, but I think probably we will integrate it here as well. I don't know if we will let them. So this will probably integrate more with our CDK integration. We can talk about that more if you want, Mark. In fact, let's talk about that because I don't think we have talked in the podcast. So can you explain people what CDK is?
Yeah, absolutely. So CDK stands for Cloud Development Kit. And it is a set of libraries to define your infrastructure resources as Java code. So if you're working in cloud environments, you might be familiar with things like Serverless Framework or Terraform or Pulumi. They're all working in the same sort of area. So what we want to do is to define our infrastructure in a programmatic way so that we can recreate those environments if we need to, and so that we can use our software engineering tools to affect changes in cloud environments. So versioning, change control, all those good things. And CDK is basically very similar. So it's a tool provided by AWS, and it's provided in a number of different languages. We'll talk about Java today, but other languages are available. And it's just a really nice way of defining your infrastructure and using the power of a programming language. So, there are some primitive objects around, primitive AWS resources, but that means that you can, use your own custom tooling to build on those primitives. And that's exactly what Micronaut has done. So Micronaut has built on top of the existing Lambda function primitives to supply additional functionality for how Micronaut builds things with Lambda, which is awesome. It just means that it's a much better developer experience. You don't have to go digging around documentation to find the information that you need. If you want to build a Micronaut function, then you just use the functionality from the library, which is fantastic.
Let me give the audience some background about the Micronaut CDK, my love story with CDK. Learning about the AWS cloud, of course, I found about CloudFormation. You can write CloudFormation with YAML and JSON, I believe. But defining everything in CloudFormation is YAML or JSON is tricky. As with all these infrastructure as code YAML representations, basically, you have to be really. Sometimes it's a bit complicated to define. And then Mark was telling me, you as a programmer, if you check CDK because you're gonna love it. And I was like, oh my god, no, another new AWS service that I have to learn about. And I was keep postponing that, and then one day I see they have a nice AWS, I think it's called AWS CDK workshop or something like that, the website, and that's really a less than half an hour commitment. And I was really excited because essentially is you write Java code and you generate the CloudFormation code. So I think basically CDK what does it is generate, it's like an above layer on top of CloudFormation. At the end of the day, you are going to be generating CloudFormation in YAML or JSON, but typically you can see the CloudFormation that is being generated for you, but you never have to go into the YAML file and edit it. And to generate basically a serverless infrastructure, something like a Lambda API gateway, a DynamoDB table, set up the whole IMM permissions with CDKs 10 lines, even with Java, which is verbose. And when I saw that, I said, this is really interesting, especially for us in the framework, because one of the challenges that we have with the integration that we have with the cloud providers, how do we really test the real functional test of I generate a Lambda function, I deploy it to AWS Lambda, and I send a request, and the request responds, right? So we have many functional tests at the code level, but at the real deployment, the real deal, like generate the jar file or the native executable and deploy to Lambda, how we do that? And we had some functional tests, but when I saw CDK, I saw the possibility of basically creating a suite of, because as you can imagine, we have like many scenarios because we support like Maven and Gradle for build tools. We support in Lambda, we can generate like a Lambda with controllers and a Lambda without controllers. We support like 3 programming languages, so you can see the matrix of combinations get exponential. And what we did is, if you go now to launch.micronaut.io and you select AWS Lambda feature, and you select AWS CDK, and you select Amazon API Gateway, and Dynamo, for example, and you click Generate Project, what we will generate is, we generate a multi-project build in Gradle or the equivalent in Maven. And in the Gradle project, you will find one folder called App, which will contain your Micronaut application as you are used to, with your application.java, etc., and your controllers, etc. And in the other folder, you will find another folder called Infra, from infrastructure. And there you will see like a couple of Java classes, which are basically the CDK code. And you will see also on the root of the project, you will see a test lambda.sh bash script. So what we generate that more than for internal consumption than for end users. But what we do is I have like a big bash script, which essentially will generate projects, deploy them to Lambda in a single bash script, send an HTTP request, check that the hello world response is coming through, and basically test the different combinations with as Java runtime, also as custom runtime when we deploy native executables. So when I saw the potential there and we put this together, this is when I was really happy and I was sleeping well at night, because before releasing a Micronaut version, and this happened to, for example, before releasing 3.8, what I do is I run this test suite that honestly takes like an hour to finish, because basically it's like creating an application, deploying to the cloud, sending a request, checking the response, etc. But when the test suite passes, then I say, okay, our AWS Lambda integration is working, and we didn't have any regression.
Yeah, that's fantastic. You know, the depth of testing there is amazing. And just to go back into like the CloudFormation YAML and CDK with Java, you know, it's very easy to understand what properties are required, and you know, you can use your IDE. You can, you know, use tab completion. You know, you can dive into methods and see what the deal is. You know, you just can't do that same sort of thing with you know, YAML. So I think from a developer point of view, if you're a developer writing Java code day in, day out, then I think you'll just enjoy using CDK a lot more than CloudFormation or something else.
I do. So if my vote counts, I strongly recommend people to check it out. We have, so you can do things, for example, we have an example in a personal repo of using Micronaut, AWS Lambda, Route 53, Certificate Manager, Amazon API Gateway, DynamoDB, Lambda. And if you are doing that through the console, that's a lot of clicks. To remember to do the same clicks the next time you are going to configure. And yeah, so check it out. Micronaut is, I am really excited about this integration with infrastructure as code that we can provide. I think CDK is just the beginning. I'm thinking, for example, that we could also, for example, add Gatling, for example, as a load test solution, and we could create like a multiplayer build with one of the builds, which would be like some load test with Gatling.
That would be fantastic. You know, the amount of people who are trying Lambda and trying it with, you know, just a couple of invokes, and you know, I'm always telling them to copy and paste my project performance test and, you know, try it out themselves on a larger scale. You know, I think that's really, really cool. I would definitely +1 that vote.
So if anyone in the community wants us to support anything for the CLI or for launch, the best place is to go to, so the repository is called Micronaut Starter. So go to the GitHub organization Micronaut projects, Micronaut-projects, and then the repo is called Micronaut-starter. Create an issue there, a discussion, and let's talk about it. that was quite a departure from the topic. We were still talking about 3.8.0. Another thing that we released related to AWS, not that they have marked here, is we added a small API for API gateway stage resolution. So that's one of the things that is a bit annoying, at least for me, when working with Amazon API gateways. You have like a stage called /prod in your URL, and so if you have a controller, you have a class in your Micronaut application called add controller with hello as and then you have like so the route that you are expecting is gonna be like dash hello / hello. The URL in API gateway is gonna be /prod / hello, right? So in the moment your application needs to do redirections from one controller to the other one, it's going to be confusing, because if you want to redirect from, I don't know, to the other controller /books, you don't have to redirect to /books, you have to redirect to /prod books. So what we added is an API called Stage Resolver. It's documented on the Micronaut AWS module that will basically resolve the stage in case there is one. So if you are like running Amazon API gateway with your own domain, then there will not be no stage, and the stage resolve is going to basically return like an empty optional. But if you are like starting to develop in Amazon API gateway before you have like a custom domain, we have like an API to that basically is you that part. So that was something that always annoyed me. So we have the API now in place.
Nice. More
about AWS, we have now integration in the Alexa part of AWS. We have integration with the local resolution. So one of the nice things of developing Alexa skills with Java and Micronaut is that Java is quite mature in terms of internationalization. We have this whole idea of message.properties with different locales. And we have integration of that in if you are like using like Netty, and we could resolve the local automatically. And you are using Alexa is going to tell you the user locale in a specific field of the Alexa request. And we basically have like integrated that into the Micronaut AWS module. So if you are like moving some part of your code to Alexa, that's going to work the same. I mentioned before in the Micronaut GCP, we support Google Cloud Events. So if you are working with something like you have like a serverless function in Google Cloud for something like cloud storage, you can use Google Cloud Events, and that will be like a better experience. Micronaut Oracle also supports Oracle Cloud Infrastructure version 3 as well. And a bunch of dependencies upgrades, as you can imagine. I will include a link in the show notes to the Micronaut 3.8.0 release. I think it's jam-packed. So check it out. One of the things that I wanted to talk with Mark about in this first episode of 2023 is AWS Lambda Snapstart. So I guess, Mark, let's start by what AWS Lambda Snapstart is, and let's go from there.
Yeah, okay. So Lambda Snapstart. So Snapstart is a new feature for Lambda, exclusively for Java version 11 at the moment. And the aim is to increase performance, specifically in regards to cold starts. So if you're familiar with Lambda, you'll notice that occasionally you get requests that just take a lot longer than others to complete. And that isn't always down to AWS, but often it's because we've scaled up behind the scenes and we've created a new virtual machine to handle maybe an increase in the traffic load that your function is receiving. So behind the scenes, we boot up a new virtual machine on a bare metal host. We start the Java JVM. We put your code into that JVM, and then we execute your code on your behalf with the request that's been made. And that all takes a bit of extra time. And after that has happened, additional requests will come to existing environments, and you won't have that sort of extra step in. With Java applications, that cold start can take seconds, and that's not very cool if you've got a customer waiting for the response on the end of a web page, for example. Maybe it's fine in some sort of asynchronous workload where you're consuming messages or sending emails or something else which is asynchronous. But for synchronous workloads, response time matters, and even though cold starts were typically fractions of a percentage, we really want to continue to optimize and improve that experience so that more and more people can bring their synchronous workloads to Lambda. So what did we do? We've released this thing called Snapstart, and this is a optimization that we've built within AWS to really look at some of the overhead that each Lambda function incurs during a cold start. Every time there's a new cold start, we have to build a new virtual machine, add the JVM, add the customer code, boot everything up and load everything into the virtual machine. And then there's going to be a process of just-in-time compilation, and this happens for every virtual machine that's just created. So if you have a high throughput system with 1,000 JVMs, then you've got this process 1,000 times. Snapstart looks to remove all of that overhead. When you upload a new version of your code, we will load your code in a separate worker, and we'll load your code onto a separate VM, separate JVM, and your code will be initialized just like it would do in a normal request. But at the end of that process, what we're going to do is take a snapshot of the entire virtual machine. We're going to split that up into a number of chunks, and then we're going to save that into a multi-tiered cache. Once that process has been finished, then any request that comes into that version of code, we're going to resume a VM. Instead of creating a new one, starting the VM, loading your code, we're just going to rehydrate a VM image. So your application will start just from where it stopped previously. So any code that's loaded, any just-in-time compilation that has happened, any resources that have been downloaded or loaded into the application will be there ready to go. We find this resume takes between 200 and 300 milliseconds. So it's a much faster mechanism of building out new environments. So as your application and your function scales up, we can restore new environments much quicker from the VM image.
We have a post that we wrote in the Micronaut blog talking about the integration with Micronaut and AWS Lambda Snapstart. I wrote a sample application. I didn't want to write so I ran the benchmarks with a Hello World application. And a Hello World application, what we were seeing is I was seeing a little bit less of 3-second call to startup. And with Snapstart, I was seeing less than half a second call to startup. The problem with the Hello World applications, and here I blame us framework developers, is sometimes they are really not comparisons for the real world. So people reading these blog posts about Hello World, this is how fast I am for a Hello World, is sometimes a bit misleading. So I wrote an application which I think is a decent representation of an application. So it has 2,000 lines of Java, has integration with Micronaut security, with OpenAPI, Timeleaf. It has a lot of transitive dependencies, same as you will have in your real application. It's not Hello World. This has applications dependencies, a decent number of dependencies as you will have in your own apps. It uses DynamoDB as persistence, right? So I was more comfortable with having that as sample code, right? So we ran the same test, and actually, getting back to our conversation with CDK, I will include a link to the project because the project is in GitHub and anyone can check it out. We have a module for load test, and the scenario that we run is we run 50 concurrent users for 3 minutes, and then a ramp up to 100 concurrent users for 2 additional minutes, which for me is honestly is a scenario that many people will not have. So many people will have less load than that in the real application. So I think that's like a decent one. And what we saw there is impressive as well. We saw like in cold startup with Java runtime without Snapstart, we were like seeing like almost 5 seconds and a half, almost 6 seconds around that. And with Snapstart, we were like seeing a little bit above 1 second. So we saw like dramatic improvements. For me, this is going to make viable for many people to use Java with serverless. So we already had like a solution for that, which was using native executable built with GraalVM deployed to AWS custom runtime. This is going to be, if you want to use the Java runtime, this is going to be a solution for you. And we really want to use to get feedback from people. We got even faster cold startup when priming the function. But before talking about those numbers, what's priming?
Yeah, absolutely. So priming is kind of the name that we've been using for preparing an application to be ready for the snapshot to be taken. So with AWS Lambda, we adhere to a project called Project Crack, which you may have heard of, which is a proposed OpenJDK project around a set of APIs for checkpointing Java applications and then resuming them later. So Project Crack, we can probably add a link to the show notes. This API allows you to create a Java class which represents methods that should happen before and after a checkpoint event. So in Lambda's case, before and after the snapshot is taken of the virtual machine. This allows you to really customize what your application is doing and what sort of information should be and can be recorded into a snapshot. So, for example, if you're making database connections like TCP connections to a relational database, if you record that the application has an open connection to a database, and that is stored within the application image, the VM image, when that application is resumed later on, it's going to think that it's got a network connection still, but obviously that network connection is probably stale and is most likely stale. So most modern libraries will realize that is a stale connection and then do some sort of retry logic or reconnect logic. You can use the before and after snapshot hooks to prepare or prime your application for the snapshotting process, and that doesn't just include closing down network connections, but it can also mean things like executing code paths so that your application is being compiled by the just-in-time compilers, so that when your application is snapshotted, all of the code that your application is going to use is already pre-compiled. So instead of having a first invoke having to compile all your classes, it's already going to be done. It's already going to be saved within the snapshot image. So when your application is resumed, you're just going straight away into compiled code, which is a big difference.
Thanks for reminding me about Crack. So that's another thing that we released in Micronaut 3.8.0. We have now integration for Micronaut Crack in the Maven plugin as well. So Crack stands for Coordinated Restore at Checkpoint. Hopefully we can have like a dedicated podcast to talk about this in the future. But so what we have is so this is currently supported by the Azul JDK. So they have like a Azul JDK, which will allow you to kind of similar to a Snapstart, I like to think as kind of hibernate your program and then resume it, right? So we have integration. We have a module called Micronaut Crack. It's basically for you means adding a dependency And the developer experience means that so if you are not using MyCode, you will have to register the resources. These resources are a kind of classes that are gonna be like called before snapshotting in Snapstart or like hibernating in Crack, however you wanna call it. And then there is like another API to when they are gonna be called after restoration, right? So in MyCode, what we have done is you as a developer, you just create singletons in your project. You annotate the class with that singleton, similar to any other singletons that you have in your applications. And then you implement an interface called order resource. Order resource basically is just what you can imagine is the resource is the API from Crack, and order is the MyCode order API, which you have seen in many places. And what this allows us to do is you can basically configure the order of your resources. So if you need the resources to be executed in a particular order, you will basically override the getOrder method and configure that. And what we have out of the box is, Mark was saying, if you have like a connections to a database, right? You have to to close that connection. So we have now integration with MyCode Data and Hikari. So if you are using Hikari as the connection pool, and you have you are working with a relational database, so it will work out of the box. You don't have to do anything as a developer. We already have those resources already in MyCode Crack project, so you don't have to do anything. We have also for other, for example, for the refresh scope. So we have an annotation in MyCode called @refreshable. And what we are going to do in MyCode Crack, and this is configurable, so you can opt out. But by default, if you have MyCode Crack, before AWS Lambda Snapstart snapshots, so when it goes to sleep, basically, what we are going to do is we are going to basically destroy all these refreshable bins. So upon restoration, when a Snapstart resumes, they will be recreated, right? So we have a couple of things out of the box for refreshables, for connection pool, etc. And we will continue working on those. So my vision for this is that you as a developer, you probably are going to include MyCode Crack in your Lambda and forget about it. The only thing that you are going to have to do is if you want to prime your application, so if you want to invoke it a lot before it gets a snapshot, this is the only scenario. One fun experiment that I tried is I took one of the Alexa AWS samples that was kind of the quiz, and I ported it to Micronaut, and many times in the Alexa skills, so you know all the paths, right? So this is kind of the user is going to ask me for a question and I'm going to give this answer. So what I did, I invoked it 10,000 times, all the paths, and before I think we have 15 minutes before the limit, so you can really invoke your application a lot. And this is going to help a lot. I mean, it's not going to be a dramatic improvement as just adding a Snapstart, but it's going to, what I am seeing is that you can get an extra half a second of a startup if you really prime your application. So just check it out without priming. Don't worry about it. Just as MyCode Crack. And my recommendation is create a singleton, implement order resource, add a couple of hello worlds there's in your logs so that you see the logs being output, and I think you're going to be impressed with the potential. One of the things that is going to be so can you clarify? So Snapstart is only supported for versions, right?
Yes. So when you come to use AWS Lambda, if you upload your code to the Lambda function, you'll see that there's a new config item, which is a function level config item, which is Snapstart. So you change that to basically be on. And then the next thing you need to do is create what is called a Lambda function version. And this is exactly what you'd expect it to be. So as you change your function code over time, you might want to have specific versions, which were specific versions from Git or some other version control system. And it's that version, when you create a version, that's exactly when the snapshotting process happens. And that just means that we can control in a little state machine how and when the Lambda function can be invoked. So you create a version, it goes into a pending state while we create the snapshot image for you and get everything ready. And then once that version is in an active state, then you can invoke that. And it just means that we can get everything ready and that you don't have this this period where not everything's ready and you're not sure what's happening. So we have this little state machine that allows you to really understand when the snapshotting is finished and then when Snapstart will have the effect. So create a Lambda function, create a Lambda version, and then you'll take maybe a couple of minutes to create. Once that goes into active, then you'll be ready to go.
Yeah, so it's simpler than it sounds. Is you go to the AWS Lambda console and basically you have to edit one setting in configuration. It's just a radio button where you have to say, I want to use the Snapstart, and then you just go to the versions tab and you click publish version. Recommendation is create your Micronaut application, upload it, enable Snapstart publish version, and then directly in the AWS console in the publish version, you can invoke a test event and you are going to see the startup improvements. So run the test event against the published version and then go back to the main and run the test events against the not version, and you're going to see the performance improvements. Yeah,
that's a good point actually. If you're thinking, I've made all the changes and I'm not seeing any improvement, then snapshotting only works on versions of your Lambda function. So when you're integrating with API Gateway, you need to specify the ARN to the Lambda function version, not just the main Lambda function. So that's often something that trips people up if they've missed a step in a guide, and that can be why. So if you're not seeing any improvements, just double check that your integration is with the Lambda function version and not with the at latest or something like that.
Yeah, another trick at Micronaut, add a resource that basically outputs something to the logs, and you have to see it if it's working. Otherwise, and the logs are going to be different as well, because there is no an initialization phase, there is a restoration phase, right?
Yeah, correct.
So in the logs, you're going to see a different output. So check that out as well. So Lambda is supported in Java. Lambda Snapstart is supported in Java 11 runtime, only for published versions. And which architectures is supported?
So it only supports x86 architectures at the moment. So it doesn't support the ARM architecture at the moment. We are working on it. So watch this space.
Cool. Are we forgetting anything that we should mention about? I wanted to mention actually something else that I mentioned in my article is, so whenever we have been lucky to collaborate in a couple of trainings in the past years about the Lambda, and the Micronaut Lambda training is a training that many people request us, and we have done a couple of line as well. People are extremely worried about cold startups. In my opinion, they are more worried than they should be, because in reality, cold startups are a rare occurrence. So the problem is that you see them when you first discover AWS Lambda because you upload the code and that's a cold startup. But in a real scenario and with the load scenario that I described, I did 70,000 requests and only 50 of those as cold startups. So it is important, I agree that it's important that cold startups are as fast as we can. But it's not like cold starts are going to be 50% of your request. Cold starts are going to be a tiny, tiny, tiny percentage of the request. It's 99.9% of your requests are going to be served in less than 83 milliseconds in our example.
Yeah, and I think your load test and the load testing that I do as well, we purposely make it bad for Lambda. So we do this burst of concurrency from nothing to however many concurrency you were specifying. So you're immediately trying to get on top of the traffic by spinning up all of these extra environments. If in most systems that I've ever worked in, you have a gradual increase over time. And those load tests are just harder to write. So it's much easier to just say, give me 100 concurrent users for 10 minutes, which just puts Lambda at its worst, which is fine. We all want to test worst case scenarios. But yeah, if you've done 70,000 invokes and you've only got a handful of cold starts, in the worst case as well, I think that's pretty impressive.
Yeah, agree. That's something that that's the problem. That basically when we are developing, that's the first experience that you have, but this is not the production experience.
Yeah, absolutely. You upload some code, you hit a cold start, you make a change, you upload your code, you hit a cold start. And yeah, I totally understand it. I wish that wasn't the case, but that's how the system works.
So what's coming in 2023 for AWS Lambda and Snapstart?
Yeah, so we've got a couple of interesting things. I think people who've probably used Snapstart have noticed that we don't support Graviton, which is our ARM architecture. So we're working on that. And also, we're not currently supporting X-Ray, which is our tracing and observability service. So we'd really like to support that with Snapstart as well. So if anybody has got any feedback on how that should work or any specific features that they would like to see within X-Ray traces for Snapstart, I'm all ears. Please send any thoughts that you have over to me on Twitter. And also, obviously, Java 17 has been out for a while now. We definitely want to be on Java 17, and we want to be using Java 17 with Snapstart. So hopefully that will be coming out soon as well. But at the moment, just like all software projects, I can't give a date.
Yeah, Java 17 is going to be a story for Micronaut 4 as well. So looking forward to Java 17 in Lambda runtimes. Anything else would you like to plug? And would you like to give now that we have you here, like any tips or tricks or that things that people should consider when working with Java and Lambda, and specifically with Java and Lambda Micronaut?
Yeah, I'm a bit of a fan. Maybe other people have different opinions, but I'm a bit of a fan of REST controllers. A lot of people develop Lambda functions as a single purpose functions, and that's totally cool if you want to do that. But I've seen that go the wrong way sometimes. So people have thought that, if their API has got 20 different endpoints, that they need 20 different Lambda functions. I'm probably the other way. I'm happy to have 20 endpoints in my REST controller and have that as a single Lambda function. If those 20 endpoints had 20 different integrations with 20 different databases, then it probably means that there's a separation that needs to happen. But if you're doing 20 similar functions or similar endpoints that have similar functionality, then I just think that should be one Lambda function, and you'll have a much easier life and easier to test and less infrastructure to manage. So yeah, I would definitely look at bringing those interactive applications with your REST controllers, using Snapstart to achieve the latency that you need. And I think, you're going to get the benefits of serverless, low overhead, low hassle from a security point of view, and patching and maintenance. And then, your application is going to scale with usage, and your cost is going to scale with usage, which is usually pretty advantageous for companies.
Yeah, the return of the serverless monolith, right?
I think monolith has these kind of bad connotations. We're not talking about 2 million lines of code, mainframes. We're talking about well architected applications that maybe people have been worried about running in Lambda functions before, because people sometimes see that people are moving single function or single purpose functions. I think that's not always, doesn't always have to be the case. I think it's perfectly fine to have, a domain or a micro, if people talk about microservices, I think it's totally fine to have microservices as a Lambda function.
Yeah, what I see is that, so for me, I agree that there is like a bad connotation to monolith, not for me. I think many companies will be best suited with a monolith. And I see with Lambda, what I see is that people can have like a big Lambda with most of their code, and maybe they can have like a couple of extra Lambdas, maybe one that sends emails with Amazon Simple Email Service. Another one which maybe, I don't know, resizes some images from an S3 bucket and saves like some thumbnails. Or another Lambda that maybe like does like a cron job. So you could have like a small things for this kind of really pure like async things that you have to do, like sending emails, manipulating things in a bucket, running scheduled jobs. But I think for many companies having like a big Lambda with many controllers, that will be really a great developer experience. And I think it will be like, as you say, it's gonna be something that scales with usage. It's gonna have less complexity. You don't have to make like a million requests to go through all your microservices. So yeah, I think I say it half jokingly about the serverless monolith, but I think there is some water into that pool, and I think in 2023 we're gonna see many people like using those kind of architectures to go to the cloud, and really excited to see what they can do with Micronaut about them.
Absolutely, yeah.
So where can people find you in Twitter or in the interwebs?
Yeah, at the moment I'm on Twitter. I'm MarkSales3. Hopefully we'll have a link in the show notes. Yeah, I'm really interested to hear people's feedback, and if you've got any positive or negative feedback, obviously happy to hear it.
I would like to wrap the podcast by thanking the Micronaut Foundation sponsors. Micronaut Foundation helps like not just framework development, but also like advocacy and talking about the framework, and for example this podcast recording. And we have several companies supporting the foundation. We have Object Computing, which is the Micronaut Foundation ambassador sponsor. We have MicroStream, which is the silver sponsor of the foundation. We have 3 bronze sponsors, Safari.net, Visor Games, and HyphenQ. We have our engineering partner, Oracle, and 2 tools and infrastructure partners such as Gradle and JetBrains. Many thanks to all of them, and also many thanks to the individual community sponsors. Without the sponsors, the foundation will not be possible, and the development of the framework will not be possible. So many thanks. Many thanks to everyone listening to the episode. My goal for 2023, and this is the start of the year's wishes, but I think we are going to fulfill this one, is to have like get back to the regular bi-weekly cadence for the podcast. So 1 episode every 15 days. So yeah, as we said in the beginning of the podcast, Happy New Year to everyone. Thanks for joining me, Mark, and we talk soon. Thanks, everyone.
Thanks, bye.